Hello everyone, this is your mathematics educator Abhinav Jha and I'm back with yet another video. So guys, this was a question that was asked in JEE Advanced 2020-22. It was a difficult looking problem, but if we knew one concept, we can do it quite easily because the calculations aren't that tough. So let's proceed how we will actually look into this kind of questions. So we've been asked to find out a limit of a composite function. So when the limit is asked of a composite function, we need to break it one by one. So if you look into the gx, it's an indeterminate form. What kind of form is it? If you put x as alpha, you will be getting log 0 by log 0. Log 0 is actually infinity, right? So this is slightly minus, it goes towards minus infinity if you look into the graph as well. So it's an infinity by infinity form. So it's an indeterminate form. Whereas if we look into the f of x, so sin pi x by 12 is a continuous function. Continuous function hai. So iski jo limit hogi, it can be calculated very basically, right? So the more complicated thing is g of x. So we have a wonderful property that is limit x tending to a, f of g of x can be written as f of limit x tending to a of g of x, right? Actually, what we need to do is just need to calculate the limit of g of x. It might be a value in terms of alpha or a numerical value which we'll be feeding here, and then we'll be arriving to a particular answer. So obviously it's a numerical based answer. We have to be correct until 2 decimals. So logically speaking, it should come a numerical value because we'll be replacing x with g of x, and then only the sign something can be calculated and the final value can be feeded. So obviously it's looking like it will be coming as a numerical value, right? So let's proceed and find out first limit g of x. This part I'm calculating, then finally I'll be substituting the value of g of x over here and I'll be arriving to the answer. So let's go how we will be doing it. So limit, it will be x tending to alpha plus 2 log root of x minus root of alpha divided by log of e power root x minus e power root of alpha. So as I told you, it's an infinity by infinity form. So we can definitely look into the L'Hopital rule, right? We can apply the L'Hopital rule and we can differentiate the numerator and differentiate the denominator because L'Hopital rule is applied for 0 by 0 form as well as infinity by infinity form. So let's differentiate. So we will have 2 into log of something, differentiation is 1 upon something. There will be 1 upon root x minus root alpha, and then again you will differentiate this root x. It will be 1 upon 2 root x, and then whole divided by differentiation of log of this thing. So log of something differentiation is what? 1 upon something. This will be e power root x minus e power root alpha. This is 1 upon something, and then again I will differentiate this something over here. So this will be differentiation of e power root alpha will definitely be 0. E power root x will be e power root x into, it would be 1 upon 2 root x. Fantastic. So up till now, it's a very simple calculation. It was not at all difficult. And we can definitely see from here that 1 upon 2 root x and 1 upon 2 root x would get cancelled. This would flip up and we will get a certain denominator as well. So let's simplify and see what are we getting. So we'll have e power root x minus e power root of alpha, and this would be multiplied by 2, and I'm writing this separately because it is in multiplication and this is neither indeterminate. This part is a determinate value. Its value is e power root alpha because if you substitute alpha, can do it because we can do it by the property of limit x tending to a, f of x into g of x is nothing but limit of f of x into limit of g of x. We can calculate that. So this value is nothing but 2 divided by e power root alpha. So we can keep it separate. And whereas this value is actually an indeterminate form, it's a 0 by 0 form. So we can use L'Hopital rule again and calculate its value. So let's see what we are getting. So if we do that, so we'll be getting alpha plus e power root of x differentiation, as we've discussed, is nothing but e power root x into 1 upon 2 root x divided by 1 upon 2 root x. And this value here, 2 upon e power root of alpha is there. I've calculated its limit. You can leave it as it is if you want to. Otherwise, you can substitute the value as well. So first of all, let's cut this part. And we all know that these two will also get cancelled because ultimately alpha will be substituted. So you also know that these two values will be cancelled. And finally, the answer that we will be arriving with would be 2. So the whole limit was calculated in 1 or 2 steps, my dear friends. If you have certain knowledge of L'Hopital rule, can certainly arrive to the answer quite quickly. Now, the job is not done. We have to finally substitute this value here as we need this value. So we will be having this. I'll just write it over here. This is going to be sine pi into 2 by 12, right everybody? So it will be nothing but sine pi by 6, which will be half, or you can see 0.5 in decimal. So this is my final answer. 0.5 is the final answer of this amazing JEE Advanced question that was asked in 2020-22. We'll be bringing you some amazing videos like this, guys. Stay tuned to this channel. Do not forget to like and subscribe this fantastic channel. See you soon. Bye-bye.